Let's start off with our first example, or I think it's our second actually. Consider the graph f of x is equal to x squared minus 2. So what we have here is y is equal to x squared minus 2. Is the inverse of this function f of x a function? Why? No. The inverse is not a function. It's a relation. And the reason for that is y is equal to f of x fails the horizontal line test. Now, that is basic level. The more correct answer is y is equal to f of x is not 1-to-1. That is the more correct answer. So allow me to take a look here, right? If y is equal to 3, for instance, right there and right there, if you take a look at it, I have 2 dots. This fails the horizontal line test because if you draw a horizontal line, it crosses 2. So if you want, graph the inverse relation. I'll leave it in your very capable hands to graph that. I'm going to move down here. I'm actually going to graph the relation last. I'm going to ask you to use your imagination and describe how the domain of the function, of this function, can be restricted so that the inverse of f is a function. Describe, imagine how I could cut this so that it passes a horizontal line test. Press pause and think about it. Okay, I hope welcome back. I don't know if you pressed pause, probably not. But anyways, very simply. Now, this is just one of many cuts. But if I cut it exactly in half, the y values on the left arm or the right arm, so if the y values will only have one x value, so over here, it will pass the horizontal line test. Let me jump over on this side. That's true. All points will pass a horizontal line test here. So really, by cutting it through the vertex, we can ensure our function is 1-to-1. Also, that was just one cut. So for instance, you could say, well, I'm going to cut it right here as well, and I'm going to include that, so that I'm only going to include this arm, if you wished, right? So, right, absolutely. However, if you cut it here and go right, well then that fails the horizontal line test. So how can we restrict the domain? Well, I'm going to say one of 2 ways. What? You can't have both. I'm going to say we are going to restrict the domain. Now I'm going to use set notation where x is greater than or equal to 0, where x is element of the reals. So easiest thing to do with parabolas in this instance is go through the vertex. 2 is x such that x is less than or equal to where x is element of the reals. So press pause, and I'm going to press pause here. I would like you to graph the inverse relation. There we are. I've graphed the inverse relation. Now, just for fun, this is just me having fun, what is the equation of this top arm? This is just for fun. This is called y is equal to the square root of x plus 2. This bottom arm is called y is equal to the square root of x plus 2, but it's reflected about the x-axis, so it's minus. Now, this is going to be very important later on. All right, let's move on. Okay. So we've done with the graphing component of inverse relations. And I know that this is nitpicking. But the inverse function, f inverse, is an undoing of the function f. For example, the operation sign can be undone by inverse sign. The inverse f, or the inverse f inverse of a function, is the reverse of operations done to the function f. So given a function f, we can algebraically solve for the inverse. So previously we've done graphing. Now what we're going to do is we're going to do the algebra component of the graphing. So I'm just going to take a guess here. We're going to algebraically derive the inverse of the following function. Now I'm just going to have fun here, and this is not right. But how could I undo this function? Well, I notice that x is being multiplied by 2 and subtracted 4. So I'm thinking that the inverse function might look something like, I'm going to take x and I'm going to add 4 and I'm going to divide by 2. Or I'm going to divide x by 2 and then add 4. Something of the sort. In other words, I need to do the inverse of those two operations. But let's get started on the formal way to do it properly. All right, the formal way to do this properly goes as follows. First thing I do is I just simply replace f of x with y. Maybe perhaps I should ask, is f of x is equal to 2x minus 4, 1 to 1? This is 1 to 1, because it's a linear function. My first step, really, now it's interesting because what did we do for every point? Wherever x was, we switched it to a y. Wherever y was, we switched it to an x. And that's exactly what we do in algebra. There we are. So I'm just going to say switch x's and y's. Now, here's the kicker. This is where the real math begins. Solve for y. So we're going to algebraically solve for y. If I'm going to isolate y, I'm going to add 4 to both sides. Divide both sides by 2. And this can be treated as my inverse function. And it's an inverse function, so I call it f. There. And it's unrestricted. Let's move on. All right, team. This is a little bit nasty. Now, I'm just going to scroll up and read the question. The question says, algebraically derive the inverse function. Well, number one, here, better be careful. This is an upward opening parabola with vertex 3, 0, or 0, 3. So g of x actually there's no inverse function exists. So instead, maybe some light may be shone so that I can see what the inverse relation looks like. So y is equal to x squared plus 3. I switch the x's and the y's. By the way, what I'm doing on the right-hand side is called annotating, right? And I simply find that annotating my work really helps me later on throughout the year when I'm taking a look at previous stuff. Also in preparation for the exam. So simply I switch my x's and y's. Now I solve for y. Now this is going to kind of get dodgy on me. Solve for y. So I'm going to subtract 3 to both sides, and I get x minus 3 is equal to y squared. So I'm going to say y squared is equal to x minus 3. I always hate when my variable I'm trying to solve for is on the right side. Just one of my quirks. And now I'm going to take the square root of both sides. And when I take the square root of both sides, just like last year, now I need to consider both positive and negative roots. This is my inverse operation. So y is equal to positive the root of x minus 3 will be an upward opening arm. Y is equal to negative the square root of x minus 3 will be the downward opening arm. And what we can see here is that the domain has to be x is greater than or equal to 3. Otherwise, you'll end up with an invalid radicand. All right. Whew, now we're working up. This is tough stuff. So very quickly, we're going to calculate the inverse of h of x. I'm just going to make a quick sketch of h of x. I'm always super suspicious of quadratics. What we notice is that this is an upward opening parabola with vertex 0, -2. And my domain says x is greater than 0. So from what is written, I'm only including one arm. In other words, it's also the positive. The x is positive. Now, think of if x is positive, what does that mean in the future when I take the inverse? It means that we are going to consider the positive arm. So let me start with the algebra. Y is equal to x squared minus 2. I switch the x's and the y's. Now I solve for y. So I'm going to add 2 to both sides. In other words, y squared is equal to x plus 2. And now, when I take the square root of both sides, x plus 2. Now here, I'm going to put the domain. X is greater than or equal to -2. So now, if you notice that when I took the square root of both sides, I only considered the positive root. And it's because, getting back to this question, if you look at the domain and range of this, it says x is greater than or equal to 0. Y is greater than or equal to -2. We included the positive arm here. So that's why I've only included the positive root. Keep in mind, don't you find it curious, the domain and the range for your regular function become the new domain, or the domain becomes the range, and the range became the domain. There's another interesting thing about inverse functions. All right, let us do the next one. What is the difference between h and j? It's all in these restrictions. Now, over here, we have the same type of parabola. If I could draw a straight line. Nope. One day. There we are. It's the same parabola, but the negative arm. And you could do the algebra, and the algebra would be identical to this, right? But what we will have is y squared is equal to x plus 2. Naturally, when we take the square root of both sides, now we're going to consider only the negative root. Why is that? Because this is the negative arm of the parabola. And if we reflect that about the identity line, it is going to appear to be like, sideways opening that way. hope that I've been able to provide some clarification. Hope you've enjoyed. Please ask questions.